Alright, so let's go ahead and, before we sketch and graph it, I did ask you guys to multiply. So let's go ahead and multiply these two. X minus 1, x plus 2. If I multiply those two, class, I get x times x is
X squared.
x times 2 is x times negative 1. Negative 1 times 2.
Negative 2.
And then we're going to add. So inside the box, what do you get? X squared plus x, or 1x minus 2. Raise your hand if you have that so far. Alright, now we're going to multiply it times x plus 3. Now if you look at this one, you should have a rectangle 3 by 2. The reason why it's a 3 by 2 is because you have 3 terms and then these 2 terms. Multiply, class. Here?
X squared. Negative 2x.
Yes.
3x.
Good.
3x.
Keep going.
6x.
Go ahead and combine like terms now. X cubed. The little check mark that helps you. It's right there. 4x squared. Plus x. 6. Raise your hand if you got that. So basically you are multiplying the polynomial twice. Let's go ahead and sketch this. I'm going to graph this using multiplicity. Just rewrite this again. So we're lucky that up here this is standard form. And this is which form?
Factor.
This is factored form. So you can actually, if you think about it, go backwards. Eventually you can actually factor it to go from here to back up there. So if I look at this now, I need to use the zero product rule. Zero product rule says each of these equal to 0. Class, x is equal to 1. X is equal to, and here. Now let's talk about the multiplicity. Where do I look? Where? On the parentheses? Where on the parentheses?
The exponent.
Everyone say degree.
No.
Everyone say exponent.
Exponent.
That's multiplicity. So the multiplicity here is what?
1. It's odd.
Someone said this number is odd. What do you do at odd?
Shoot through.
Shoot through. Multiplicity? Odd. Shoot 3. And multiplicity is 1. Odd. Shoot 3. Make a sketch. Here is x equals 1. X equals negative 2. And x equals negative 3. Yesterday's lesson we talked about its end behavior. So class, what type of function is this? What function family? It's cubic. Because the highest degree is 3. Cubics start where? They start down. And how do they finish? Up. Yesterday we learned that if the a value is negative, these will flip across the x-axis. Okay, they're just gonna switch. Should I switch it, class?
No.
No, we do not, because this is positive, there's no negative. So each of these you're gonna go through it. And one extra point that might help you is your y-intercept. The constant in standard form gives you a -6. Let's just say this is -6. And count by 2's. Shoot through it. Shoot through it.
The -6 is on the positive.
Yeah, that didn't make sense. Good job, you. I was like, how do I get up there from down here? Yeah. And that's a brief sketch. You can graph your x-intercepts. This is -3, -2, this is 1. And let's just apply end behavior because we did this yesterday. As x, what word do we use for the arrow? Approaches positive infinity. So basically we're going both left and right. If I go in that direction, what's happening to my graph? What's the last thing I'm touching? The arrow. Where's the arrow going?
Up.
Up, which means what? Positive. As x approaches negative infinity, so I want to know what happens if I'm going left. What happens, class? As with x approaches negative infinity. So, if we're clear, this is yesterday's lesson. They call that end behavior. And some old stuff. This is your relative max, relative minimum. You have 3 x-intercepts, you have 2 turning points, and you have a y-intercept of -6. Yeah.